Hello, Professor. My name is Luis Nieto. I'm gonna be doing my Chapter 30 exam. For Part A, I'm gonna choose a problem. Where is it? 30.10. Part A. Alright. The LC circuit, which you have in figure 1, contains an inductor with 45 microhenries. The charge and current of the circuit oscillates with frequency for 445 hertz, and the maximum capacitor is a charge of 9 megahertz. Find the capacitance of the capacitor. Alright. We have the given data, the henries, so that's the length, the frequency, and we have the columns, right? We already know that one. So 45.0 microhertz. If we pass that to henries, it's gonna be 45.0 10 times -6 henries. All right. The frequency 445 hertz, and this is gonna be 9.00 megacolumns, and we're gonna change it to columns, so 9.00 10 times -3 columns. Alright. First of all, we need to convert the frequency to angular frequency. We know this, we use multiply 2 pi by frequency. 2 pi times 445. Let's get that to calculator. Okay, and we got 2,796.02.17, sorry. Radians per second. The formula that we're going to use is this one. Square root length over columns. Alright, and since we're looking for the columns, we're going to put 1 over a little bit square. Alright, now let's get to the problem. It's going to be 1 over 45.010 times -6 multiplied by 2,796.17. And we'll get that to the calculator. It's 1 over 45 10 times -6, close, open, 2,796.17, and I got 2.84 10 times -3 farads. That's the answer for part A. Now we'll go with part B. All right. So we have the given data. Find the maximum current in the circuit. We already have it, to be honest. So we're just gonna write it down. It's gonna be 2796.17 radians per second. Alright, then go frequency, perfect. Now we look for the Mx, and that's multiplying the angular frequency with the charge, right? So the initial one This is a formula we're gonna use. So 2,796.17. Let's open a parenthesis so we can 9.0010 times -3. And we'll get that to the calculator too. And I got 25.2 amperes. Perfect. Now we can go with part C. So for part C, you construct a LC circuit that constrains a 50 microhenries inductor and a 455 microfarads capacitor. At t equals 0, the capacitor has its maximum charge of 0.400. Find the first time after t0 when the capacitor charge is 0. All right. The given data that we have. Let me write it down so I have space right here. Given data of the length that is 5.00 megahertz, 50.0, sorry, 50.0 megahertz, sorry. Let's pass it to pound, 10 times. I'm gonna see henries. And let me see, 455 microfarads. So you pass it to farads, so 455 10 times -6 farads. Perfect. Remember, we already have the formula that we're gonna use for this. I show it to you. It's length becomes, let's see. Alright, now we'll get that to the calculator. 1 over square root of 50.0 10 times -6. I close here, open. 455 10 times -6. And I got 6,624.72 radians per second. All right. Now, to get the time, we're gonna time pi over 2 ones. All right, correct. So pi over down 2 multiplied by 6,624.72. And we'll get that to the calculator. Pi over 2 times 6,624.72. I got 2.37. 10 times -4 seconds. Amazing. Now, we'll go with part D. Given data. Find the magnitude of the current in the circuit at this time. Yeah. So, the given data, we have the radians per second in the columns ready. 6,624.72 radians per second, am I right? Yeah. And the columns, 0.400 10 times -3 columns, correct. So same as the other one, we look at the IMAX. So 6,624.72. Remember, we multiply the radians per second by the columns. And 0.400 -10 times -3. Let's get that to the calculator. And I got 2.65 amperes. Correct. Now let's go with part E. So for part E, the total energy in a LC circuit is 0.800 joules. At a certain instant, the capacitor charge is 5.3. And the current is 8 amperes. At the moment, electric and magnetic energy are equal. Find the capacitance. So we have the charge already, and the columns and the joules. So given data, so it's 5.30, and we'll see if we want to pass it to columns. If we want to pass the columns, it's going to be 5.30 10 times negative 3 columns. And the joules, we already have the joules on 0.400 joules. Perfect. To find the capacitance, we're going to use this equation. Square 2 times columns. Alright, perfect. So I'm gonna use 5.30 10 times negative 3 square over 2 times 0.400. And let's get that to the calculator. So 5.30 times negative 3 goes to 2 times 0.400, and I got 3.51 10 times negative 5 farads. Amazing. Now we'll go with part F. So for part F, find the inductance. So find the inductance, we already have the amperes and the joules. That's a given data that we need for find the inductance. And the joules is 0.400. To find inductance, that the formula that we use is this one. So multiply 2 times the joules and then the amperes square, right? So right here, 2 times 0.400, then 8.00 square. All right. Let's get that to calculator. 2 times 0.400 over 8 square. And I got 1.25 10 times negative 2 henries. Perfect. Now we'll go with part G. So for part G, find the angular frequency of the oscillation. We have the length and the capacity for this part. The length, 1.25 10 times negative 2 henries. And the capacitance, 3.51 10 times negative 5 farads, right? All right. The formula that we show at the start, then let's put the capacity. So it's gonna be 1 square root and multiply the 1.25 10 times negative 2 by 3.51 10 times negative 5. And let's get that to a calculator. Square root, all right. Now 1.25 10 times negative 2. 3.51 10 times negative 5, close right here, and I got 1,510 radians per second. Did I mark down? Okay, so we should know the answer. Perfect. Now we have the part H. So for part H, an LRC series circuit has an impedance of the microhenries and a capacitance C. Without the resistor, the angular frequency of oscillation is 624 radians per second. With the resistor, the angular frequency is 208 radians per second. Find the value of C. All right. Perfect. So we have the given data. And this is going to be 42.0 henries. If we pass that to Henry, so 42 10 times negative 3 henries. All right, and the radians, so 624 radians per second. Perfect. Formula. The capacitance formula is 1 over length multiply the initial. All right, square, yeah. Okay. Now, solve it. So, 42.10 times negative 3 multiplied by 624 square. And let's get that to the calculator. 1 over 42 10 times negative 3 624 comes, and I got 6.11 10 times negative 5 farads. Perfect. Now we go with part A. Sorry. Find the value of R. For this, we have the initial. Oh, wait. I'm trying to remember. All right, so we have the initial angular frequency. That's 624 radians per second. The frequency, that is 208 radians per second. And we have the length. It's 42.0 10 times negative 3 henries. Amazing. To find the R, the equation that we're going to use is R over 2 times the length and square. Yeah. Equal initial angular frequency square by the angular frequency square. Amazing. Now let's get to the calculation. All right. We can start doing that by now, to be honest, because, all right, so 2 times 42 negative 3, so R equal 0.084. This is going to be equal. Let's get this to calculators. 624 square minus 208 square. Square root 346 112. All right. Now, if we change the, let's multiply both sides by the 0.084. 0.084, 84, All right, let's get that. 3, 4, 6, 1, 1, 2. Multiply by 0.084. And I got 49.4, which I'm perfect. That's R. So that's my exam, chapter 30. Thank you, Professor.